Okay. Now, we did do this from last week, but I just want to hit it again and make sure we're good. So on a 45, 45, 90, and you can generate any 45, 45, 90, but obviously the easiest one for us is a 1, 1, radical 2. Remember, sine of 45 is square root of 2 over 2. Cosine is going to be the same. Tangent is going to be the same. And then you got cosecant, secant, and cotangent. So remember, we talked about if you hit sine of 45 degrees, it's going to give you a decimal. You got to make sure you understand that that's equivalent. Okay, sine of 45 degrees is going to be a decimal. Square root of 2 over 2 is the exact value of it. And we cannot get the exact value for all of them, but we want to get the exact value for as many as we can. So we can do 45, and we can do 30 and 60. So here, the 30 and 60, we take an equilateral triangle, length 2, cut that in half. That becomes radical 3. And so your values should be, don't worry about that bottom one, 1/2, square root of 3 over 2, square root of 3 over 3 after you rationalize, 2 radical 3 over 3, and square root of 3. And if you notice, all the 60-degree ones, they're going to use the same values but in different spots. Cosine of 30 is going to be equivalent to sine of 60. Okay, and then sine of 30 is equivalent to cosine of 60. So that's for a 30, 60, 90 triangle. All right, is that the next four? You got that little figure there? All right, sine of theta. All you need to do here, sine of theta is what's the ratio? It would be opposite over hypotenuse, which would be A over C, right? Go ahead, fill in all those. Just fill them in if you would. And then make sure they match. Okay. You guys know?
No, I'm good. Because they're in my car. Thank you.
Save you some time. All right. You got, it says co-function identities right below there. So you got a little bit of room to the right. I'm just going to try to build up a little bit what's going on here. Sine of theta is A over C. Sine of theta, opposite over hypotenuse. Cosine of alpha is adjacent over hypotenuse. Adjacent is A, hypotenuse is C. So cosine of alpha is the same thing, right? So sine of theta is equal to cosine of alpha. Now, what does theta plus alpha have to add up to? What does that have to add up to? Maria, what do you think? 90. Has to add up to 90. Because you have a right angle there. So that equals 90. So alpha equals 90 minus theta. So that means that the sine of theta equals the cosine of 90 minus theta. And so that's always going to be true. We just kind of proved it. Very informally, but we proved it. Because those two angles have to add up to 90. So it doesn't matter. And let's just start with obviously acute angle. If I take the sine of 10 degrees, okay, I'll make sure I'm in degrees. I am. I get that. What does it have to equal in terms of the cosine? It has to equal cosine of what? Alex?
90 minus 10.
Well, what's 90 minus 10?
80.
80. So cosine of 80. 0.1736. Okay, that's always going to be true. So it doesn't matter what angle you pick, sine of 40 has to equal the cosine of 50. All right, always true. Now take a look at your other relationships that are going to be the same. Similar to that. Cosine of theta is going to equal the sine of alpha, right? Cosine of theta equals the sine of alpha. Well, cosine of theta. What's alpha equal? We said it's 90 minus theta, so it's the sine of 90 minus theta. So it reverses. What about tangent? Tangent's A over B. What does that equal over there? It equals cotangent. So the tangent of theta equals the cotangent of alpha. Well, we said alpha is, that's not cost, it should be COT. Sorry. Cotangent. And that is going to be cotangent of 90 minus theta. These are your co-function identities. These are your co-function identities. So right there, sine of theta equals 90 minus cosine of 90 minus theta. Tangent of theta equals cotangent of 90 minus theta. And put these under those co-function identities. And secant equals a cosecant. Well, if you look at the names, sine, all this one is a cosine. You just throw a CO in front of it. Tangent, throw CO in front of it. Cotangent. Secant, cosecant. And that means they're complementary angles. That's kind of where those names come from. Okay, because they're going to be equal to the complement. So secant and cosecant. And then if you just flip it around, cosine of 90 minus theta. Or cosine equals sine of 90 minus theta. Cotangent equals tangent of 90 minus theta. Cosecant equals secant 90 minus theta. And just look at this here. So think about this. So the sine of 32 degrees equals 0.5299. Then what can you tell me without touching your calculator? Then what has to be true? The sine of 32 degrees equals 0.5299. Then the cosine of what? Whatever 90 minus 32 is, which should be 58. Then the cosine of 58 has to equal 0.5299. Okay, so cosine 58.5299. Okay, always going to be the case. If cotangent of 53 degrees equals 0.7536, then what has to be true? Then the tangent of 90 minus that, which is what, 37, equals 0.7536. So tangent 37.7536. Okay, so that's going to be true with these co-function identities. Secant and cosecant, tangent and cotangent, sine and cosine, always going to equal the complement. All right, now part of what you have to do is you have to solve for missing sides and missing angles. All right, I'm not going to spend a ton of time on this because you did this a lot probably in geometry and a lot in algebra too, but at least I want to hit it. So if A equals 15, okay, and theta equals 24 degrees, okay, we want to find everything we can. Now, finding alpha is not hard at all. Just finding out. That's going to be 90 minus 24. So that gives me 66 degrees. And what do I need to find? I need to find B and I need to find C. So let's find B first. Okay, let's find that first. All right. Any ideas how you're going to go about finding that? So take a second, think it through. Good morning. What do you got for me? Oh, for Gabby? What do you got there?
It's for mentoring.
Oh, some candy?
Yeah.
Oh, nice. Got a bribe him. All right, how am I gonna set that up? Max, what do you got for me?
I'm not sure.
No. Okay, here's what we gotta do. You gotta take a look at what we got. I know this angle is 24 degrees, and I know this side is 15, and I'm looking for this side. So in relationship to this angle, that's the opposite side, and that is the adjacent side. Which trig function uses opposite and adjacent? Tangent. So tangent of an angle is equal to opposite over adjacent. Well, we know that, and you need to know 2 of the 3 parts. So we know the angle is tangent of 24 degrees. Opposite is 15. Adjacent is B. So this is what we're looking for. So usually what I do is I make that a proportion. What you're doing is you cross multiply. B times the tangent of 24 is equal to 15. Divide by the tangent of 24. And so I get B equals 15 divided by tangent 24. 33.69 degrees. Or no, not degrees, sorry. That's going to be the length. All right, if you take, so make sure you understand this. If I take 15 divided by that answer, that should equal the tangent of 24 degrees. Okay? That ratio, 15 divided by that side is equivalent to the tangent of 24 degrees. So that's how we find B. Now you can use this in the Pythagorean theorem. You can use a squared plus b squared equals c squared. You can do that. Or I can use, if I'm looking for c and I know a is 15. Now I tried not to use any rounded off values when at all possible. So I'm not going to use a squared plus b squared equals c squared. I'm going to use the 24 degrees. I'm going to use opposite, and I'm going to use hypotenuse, which is the sine function. So the sine of 24 degrees will equal 15 over c, and then I'm just going to do the same thing. It's going to be c times the sine of 24 equals 15. Divide by the sine of 24. And then I get c equals, 15 divided by sine of 24. 36.88. Okay, 36.88 units. I don't have any units on there, so we'll just go with that. So that's how you find on a right triangle. You can set up sine or cosine or tangent depending on what you're given and what you need to find for that one. All right, where are we at there? Top of the next page. All right, you don't have this on here. This is just to help me. You've already done it enough, but I'm just going to have it so I have it to refer to. All right, sine is A over C. Sine is A over C. Cosine is B over C. Tangent is going to be A over B. And then cosecant is C over A. Secant is C over B. And cotangent is B over A. All right, I want you to take a look. What does 1 over, like I said, just pay attention, the sine of the angle equal? What is the sine equal? Equals A over C, right? I'm going to do that. So that becomes 1 over A divided by C. All right, what does that simplify to? 1 divided by A over C. What's that?
C over A.
There we go, C over A. And what is C over A equivalent to? C over A is equivalent to cosecant. So 1 over sine is equal to the cosecant. Does that make sense? At least does that mathematically make sense? Because you do 1 divided by A over C, and that becomes C over A, so it equals the cosecant. What about 1 over the cosine? 1 over the cosine of the angle. Well, cosine is B over C, so you got 1 over B over C, which is C over B. Well, what does that equal? Secant. And then same thing with tangent. 1 divided by the tangent is equal to 1 over A over B, which is equal to B over A, which is equal to the cotangent for that. So these are our reciprocal identities. Now that's on your sheet. Sine is equal to 1 over cosecant. Cosine is equal to 1 over secant. Let me come back here in a second. Okay. And this is one we did earlier. We just started with 1 over sine is equal to cosecant. Secant of theta is 1 over cosine. Cotangent's 1 over tangent. These are your reciprocal identities. Reciprocal, remember, means you flip the fraction. Here's that. Now, this helps us a ton because what is the cosecant of 35 degrees on your calculator? Okay, use your calculator. What is the cosecant of 35 degrees? What's the problem?
Yeah.
All right, what's the cosecant of 35 degrees? What's the problem? Where's your cosecant button at? We're lost. Is there a cosecant button? No, but what does the cosecant equal? The cosecant is the same as 1 over sine. This is how you have to use your calculator. So it is equal to the 1 over the sine of 35 degrees. That's right. That's how you got to calculate it. There is no cosecant button. It is not that little inverse sine button, or that doesn't work. So for the cosecant, you got to do 1 divided by sine 35. Okay, 1.743 for that one. Max.
I'm getting like a completely different answer than that.
All right, go to mode.
Okay.
Are you in degrees?
Yes.
You are?
Fraction, I'm in radian.
Okay, fix that.
Okay.
And in these next few chapters, you always got to double check what mode you're in. Because a lot of times we'll be using radians. You got to be in radian mode. And then a lot of times we'll be in degrees. You got to be in degree mode. Okay, for that one. So if I want to know what the cotangent of 20 degrees is, I got to do 1 over the tangent of 20 degrees. 1 over the tangent of 20 degrees. Whoops, I hit the wrong thing there. Clear. 1 divided by tangent 20. For that. Okay, so that's how you got to find those. All right, now, I tend to forget you guys haven't seen this yet, or I don't think you have. Tangent of theta is equivalent to sine of theta divided by cosine of theta. And cotangent of theta is equal to cosine divided by sine. These are extremely important as we kind of move forward. Now, first of all, let me show you on your calculator. So if I do tangent of 20 degrees, I'm going to say that's the equivalent to the sine of 20 degrees divided by the cosine of 20 degrees. And I get the same decimal. So the calculator verified it. Now, to prove it in all cases, I'm just going to go up here. Sine divided by cosine. I'm going to go over here. Sine of theta divided by cosine of theta in a right triangle. Well, what is the sine of the angle? The sine of the angle is A over C. What is the cosine of the angle? It's B over C. If I simplify that, that's A over C times C over B. The C's cancel, and I'm left with A over B. Well, what's A over B equal? A over B equals tangent. So that proves it for all cases. So sine divided by cosine, so those are interchangeable. And then the cotangent would be the same, except you'd flip it and we'd get B over A. So those are quotient identities. So you got tangent and cotangent. All right. Let's just say next, Pythagorean identities. Okay, you got that. Work to the right here a little bit to save room under 1, 2, and 3. We know, I'm going to do two things here. You know that A squared plus B squared equals C squared. Okay? Pythagorean theorem. All right, what does the sine of theta equal on that triangle? Abby, what's the sine of theta equal? The ratio. A over what? Make sure you do opposite over hypotenuse. So A over C. What's the cosine of theta equal to, Gavin? What's the cosine of theta? What is the ratio for the cosine of theta on that triangle? B over C. All right, we're going to use that here in a second. Go back to your Pythagorean theorem. Divide everything by C squared. And what you can do is you can make this as A over C, and I can just put the squared on the outside, plus B over C, and put the squared on the outside, and C squared divided by C squared is 1. Well, A over C, we just said, is equal to what? Sine of theta. B over C is equal to what? Cosine of theta. So this now becomes sine of theta squared plus cosine squared theta equals 1. And a little bit here on notation. If you have sine of theta squared, we are going to write this like that. That's kind of how it's accepted. You're not squaring the angle. Okay, you're not squaring the angle. You're taking the sine of theta and you're squaring it. Okay, that's different. And so cosine of theta, if we're squaring that whole thing, we write it as cosine squared theta. Okay, so now right here, I get sine squared theta plus cosine squared theta equals 1. That is the first of our Pythagorean identities because they come from the Pythagorean theorem. So that would be number 1. Sine squared plus cosine squared equals 1. All right, now watch this. Let me see what we got there. 1 plus. All right, go ahead and write that one down. I'll just show you where it comes from. The top one is the most important by far. We use that a ton. And now 1 plus tangent squared equals secant squared. All right, this is from this first one we can get these other two. So let me just show you. Not that you need to know this and memorize it, but I want you to understand it. Start with that. I'm going to divide every one of these by cosine squared. Cosine squared theta equals 1 over cosine squared theta. Well, what does sine over cosine equal? So we just learned that sine over cosine equals tangent, and if they're both squared, then it becomes tangent squared. Cosine over cosine squared is 1. 1 over cosine. We just learned that to be secant. And if they're both squared, it's secant squared theta. So that's how we get that second one. 1 plus tangent squared equals secant squared. And then the last one is 1 plus cotangent squared equals cosecant squared. Okay, those are Pythagorean. So we've done a lot of what we call identities today. Let me go back. You got your reciprocal and quotient. Sine equals 1 over cosecant. Okay, cosine equals 1 over secant. Tangent, sine over cosine, cotangent's cosine over sine. Comes up a bunch. We got our cofunction. Where are those at? Here. Okay, sine equals cosine of 90. Tangent equals cotangent of 90 minus. Same thing over here. Okay, for those. Cosecant equals secant of 90 minus. All right, now the last thing here. All of those come under the umbrella. Those are all what we say fundamental identities. So using anything there, we want to find the indicated trig value. Now, normally you would probably just make a triangle and solve it that way, and I'm never going to tell you not to do that, but under today, since it says use a fundamental identity, we're going to use anything that we had on these previous slides. Okay, I don't want to draw the triangle. So for first one here, and let me show you what I mean. Sine of theta equals cosine of theta equals 2/5. Cosine of theta equals 2/5. We want to find sine of theta. Okay, think of an identity that contains both sine and cosine. Okay, anywhere on those sheets. Think of an identity that contains both sine and cosine. Okay?
Or if the sine of theta equals 1 over, is it cosecant theta? It's that first one.
Is that first one?
Yeah.
Sine of theta equals 1 over cosecant. But this is cosine.
Right, yep.
Okay? But that's we just got it. That's good. Just to try something and see where it fits or doesn't fit. Probably is a Pythagorean identity. What's the first Pythagorean identity we got? Sine squared plus cosine squared equals 1. As long as that will work. Because I'm just missing okay. Now once you get this will make sense, but maybe the first couple times it's a little bit fuzzy. Remember, cosine squared theta is the same as cosine of theta quantity squared. Know that difference. Well, what did we just say cosine of theta equals? Cosine of theta equals what? 2/5. That does not replace, some people want to put that in for the angle. It goes in for the whole thing. So it's really going to become 2/5 squared. So I'm going to have sine squared theta plus 2/5 squared equals 1. Okay, it takes the place of the cosine of theta, whole thing. Now we kind of keep going and get sine squared by itself. So sine squared theta, 2/5 squared is plus equals 1. Subtract 4/25, and you get 1 minus 4/25, which is going to equal 21/25. Now we want to know what the sine of theta equals. That's sine squared. Well, just like an x squared, take the square root. Take the square root. Square root of both. And now that's going to give me sine of theta equals the square root of 21 over 5, because the square root of 25 is 5. All right, so that's sine of theta. Could have done a right triangle, drawn it out, but I don't want to use an identity until we get used to these. All right, so that's the first one. Second one, secant of theta. Find secant of theta. Well, I can either use cosine or I can use sine. It doesn't matter because I know them both. Well, what does secant of theta equal? Equals, if you go up to the top, secant of theta equals 1 over.
The sine of theta.
No, you wrote that wrong. Should be cosine. Ooh, that could be bad down the road. Here, right here. Okay, secant's 1 over cosine, cosecant's 1 over sine.
I have that.
Don't you have?
Yeah. I have that. Sine.
Oh, that's CSC. I thought it was SEC. Sorry. Lying to you. I misread it. Okay, so secant of theta equals 1 over cosine. So that means it's going to be 1 over 2/5. And what does that reduce to? That reduces to 5/2. Okay, so secant of theta equals 5 over 2. And the last one is the tangent of theta. And sometimes there's going to be more than one way. Sometimes there's going to be more than one way. And sometimes there's only one way. Just depends. All right, what are our quotient identities? Tangent of theta equals sine divided by cosine. Since we know them both, let's use that. Tangent of theta equals sine of theta over cosine of theta. And so tangent of theta, sine of theta is what? Square root of 21 over 5 divided by cosine of theta, which is 2/5. That becomes the square root of 21 over 5 times 5 over 2. Cancel your 5s. Tangent of theta equals square root of 21 over 2. There we go. Now, like I said, I wanted to use the fundamental identities. If you are not told that to do those, you can make a right triangle, put your angle here, adjacent's 2, hypotenuse is 5. You can figure out this missing side and then do it that way. Okay, but you got to understand that these all work together. They all work together. Okay, page 538, that's 5 through 8. 5 through 8. We'll finish up this section tomorrow. You get a little bit of class time. Then hopefully I'll be able to go over your grades with you. If you need me to.